Today we're going to talk about simplifying expressions by combining like terms and using our distributive property. When you combine like terms, you need to combine terms that are the same. So the first thing we need to do is figure out what a term is. A term can be any real number, a variable, or the product of real numbers and variables. And terms are going to be separated by addition and subtraction signs. So if you look at this expression that I have written here, it has four terms. The red term and the blue term here are terms where we have a product of a real number and a variable, so this coefficient and this variable together. This green term is just a real number, just a number, and then finally this z is just a variable. So terms can be made up of any of these different combinations. Now, the thing about combining like terms is when you combine them together, your terms have to be the same. And what makes them like terms is that they have the same variables with the exact same exponents. So here are a few examples of like terms. If you look at these, you'll see that they have the exact same variables with the exact same exponents. So this one here, 3z, and 4z, they both just have a z as their variable. For 5ab and 10ab, the variables they have in common are an a and a b. And then finally, my last example, 7x squared and 9x squared, they both have an x, but not just that, they have the same exponent too, x squared. So these are examples of like terms. Now what I'm going to do is show you some that are not alike. Okay, these are unlike terms. And some of them, I think you'll be able to tell. These are unlike because they're not even the same variable. We have an a and a b. But they get a little trickier as we go down. So 5a is not the same as 10ab. They both have an a, but they don't have the exact same variables. In order for them to be like terms, they would both have to be an a and a b. And then finally, if we look at this, they both have x's, but remember, this one's just 7x. This one is 7x squared, so even though they're the same variable, they're not the same exponent. So in order to be a like term, we're talking about the same variables and the same exponents. And what we're going to do is we're going to talk about how we can combine like terms. And we're going to relate this to what we did yesterday when we were working with expressions. So we're going to start off writing an expression for this problem. We're going to have W represent our watermelons and S represent our strawberries. So if we think about this, I can say I have 3 watermelons plus 3 strawberries plus 2 more watermelons plus 1 more strawberry. And this expression goes ahead and it shows me, it represents what I have in this picture. The problem is this is not simplified. So what we're going to do is we're going to combine our like terms. When we combine things together, we're looking for things that are the same. So in this case, my watermelons and my watermelons. I can see I have 3 watermelons and 2 watermelons. So if I wanted to find my total number of watermelons and combine these terms together, I would have 5 watermelons. Then I have 3 strawberries and 1 strawberry. And if I combine all my strawberries together, I would have 4 strawberries. This is as much as we can simplify it. Sometimes people will try to put these two things together and they'll get 9WS. Okay, but I want you to think about what that means. That means you have 9 watermelon strawberries. Okay, now first of all, I don't know what a watermelon strawberry is, but second of all, we don't have 9 watermelons and we don't have 9 strawberries, so we know that can't be the answer. Okay, so when we simplify things, we're just combining our like terms together to get our answer. So I'm going to show you 2 different ways that you can combine like terms. And you get to decide which method you like the best. Okay, I'm just going to show you 2 options. So the first option we have is using a chart. And when you use a chart, the first thing you want to do is identify what you have that have the same terms. So when I look at this, I see I have a 5x and I also have a 3x. Both of those have an x, so they're in common. And what I'm going to do is I'm going to put them on one side of this chart. I have 5x, and then I have plus 3x. And then I'm going to look for other things that are the same. I see that I have just a constant here that's a -2. And I have a constant here that's a 7. Since these don't have any variables, those are considered like terms. And I'm going to put them here. I want you to notice, though, when I circle the term, I'm circling the addition or subtraction sign that goes with it. That's going to help me combine these together. So now I have 5x plus 3x. So 5x plus 3x, that's going to give me 8x. When you combine like terms together, you combine your numbers, but your variables don't change. If we think back to our watermelons, 5x would be like I had 5 x's. Okay, and 3x would be like I had 3 x's. So when I combine these together, you can see I have 8 x's. So I don't do anything like 8xx or anything like that. It's just you combine your numbers and your variable stays the same. Now here I have -2 plus 7. You can also think of this as 7 minus 2. And 7 minus 2 is 5. And since it's a positive 5, I'm going to put a plus sign in front of it because that will help me when it comes to writing my simplified expression. My simplified expression is going to be 8x plus 5. Okay? So we're going to go ahead and do the next one together. If you think you're ready to try it on your own, go ahead. You can pause the video. But I'm going to start by identifying my like terms. So like terms have the same variable. Oops, that's terrible. Hang on. Same variable and same exponent. So I have an x squared here, and I have another x squared over here. So I'm going to write -2x squared plus 9x squared. And then I'm going to look for my other terms that are the same. Here I have a 4x and a 7x. So I have a plus 4x and a plus 7x. And finally, the last term I have here doesn't have anything to combine with it, but I still don't want to forget it, so I'm just going to add it to my chart over here, -3. So now let's combine things together. So I've got -2 plus 9, or again, you can think of it as 9 minus 2. That's going to be 7x squared. And then I've got 4x plus 7x, which is 11x. And finally, I'm going to bring down this -3. Now this 11x, I didn't put a symbol in front of it. I probably should have. We have a positive 11x, so we're going to put plus 11x. And so then my last step would just be to write this problem without the chart there. So I have, oops, goodness. Let me fix that. Well, technical issues. 7x squared plus 11x minus 3. Okay, so that's our first method for combining like terms. And if you like it, you can use that method. I am going to show you one that's a little different. This is the one I use more often than not. We're still looking for like terms. Okay, so I'm still going to go through. I'm going to look for my terms that are the same. I have an x, I have a y. Here's another x. And this time I'm going to circle them. And I'm going to make sure I circle them with the addition or subtraction symbol in front of them. And those are the only two that are the same. So this time, instead of putting them in a chart, I'm just going to look at them together like this, and I'm going to do the math in my head. So 2x plus 6x. 2x plus 6x is going to give me 8x. And then I'm going to look for more terms that are the same. So I have -4y and a positive 10y. So I'm going to put these two together. 10y minus 4y is going to give me 6y. And it's a positive 6y, so I'm going to put a plus in front of it. And then finally, nothing to combine with this -3. So that -3 just comes down here. So same idea, except we're just not filling in a chart. So let's try this next one. So I've got an 8a. I want to look for something I would combine with my 8a. It's going to be this -2a. And then we know they're like terms because they both have an a. So 8 minus 2 is going to be 6a. We don't want to forget that variable. And then I've got my b's. So I've got a 4b plus b. Now this is what we call invisible math here. There's no number or coefficient listed here, which means the coefficient is a 1. We have 1b. Okay, so if there's no number there, you just automatically know it's 1. So in here, I have 4b plus 1b, which is going to give me 5b. And then, like I said before, there's nothing to add on to it, but we have this constant here, minus 7. And we'll just make sure we add that to the end here. So combining like terms, use whichever method you like, but we're going to use this idea of combining like terms as we make more complicated expressions and equations. And one thing we're going to look at is called our distributive property. Now, we looked a little bit at our distributive property yesterday when we looked at expressions that look like this. And remember, this number in front here tells me how many groups I have. So this expression really means I have 3 groups, and then inside each group is 2x plus 9. Okay, so once you understand what this problem is saying, there's like a long way you can do the problem and a short way to do the problem. Both will give you the right answer. I'm going to show them both to you. So if I have 3 groups of 2x plus 9, what that means is I have 3 groups of 2x plus 9. So here's one group, and here's a second group, and finally, here's a third group. And what I can do is I can use what I know about combining like terms to do this problem. So I know I have this 2x and this 2x, which has this plus in front of it, sorry about that, and this 2x. So 2x plus 2x plus 2x is going to give me 6x, and then I've got 9 plus 9 plus 9, which is going to give me 27. Now, this is how we would do the problem by expanding it and then combining like terms. We can also use something called our distributive property. What our distributive property does is it's a shortcut. It takes what's outside our parentheses and we multiply everything inside our parentheses by it. Because remember, we have 3 groups. And if we know this is what's in each group, that means I'm going to have 3 groups that have a 2x in them. So I know without even writing all this stuff out that I'm going to have 2x plus 2x plus 2x, which is going to be 6x, because 3 times 2 is 6. And then I know I'm going to have 3 groups, and each group is going to have a 9 in it. So 9 plus 9 plus 9, which is the same as 3 times 9, is going to give me 27. So we're going to end up with the same answer. It's just 2 different ways to find it. The distributive property is definitely the way that's going to be faster for you as your problems get more and more complicated. So that's what we're going to practice. So I'm going to take this number out front, my 2, and I'm going to use it to multiply everything that's inside of my parentheses here. So I'm going to do 2 times 3x. 2 times 3 is 6, and that x just stays here, because essentially it's saying I have 2 groups that have 3x. And then I'm going to take that 2, and I'm going to multiply it by negative 6. So 2 times negative 6 is negative 12. And that's our problem. So we're talking about simplifying our expressions, putting them in simplest form. And in order for an equation or an expression to be in simplest form, we have to have no like terms and no parentheses. So when you look at an expression, the first thing you want to think about is, do I have any parentheses? And if you do, we need to get rid of those parentheses. So we're going to start here with this negative 8, and we're going to multiply this 2x. So negative 8 times 2x is going to give me negative 16x. And then next, we're going to take that negative 8, and we're going to multiply it here by negative 1. Negative 8 times negative 1 gives me positive 8. Now this 5 is not inside my parentheses, so we're not going to multiply by it, but it's still part of this expression, so we still have to bring it down. So now I've gotten rid of my parentheses, but I do have some like terms. So sometimes you're going to have to go back and finish up your problem by simplifying your like terms. So for this problem, we'd have our negative 16x plus, we have 8 plus 5, which is 13. So negative 16x plus 13. And that's how we use our distributive property and combine like terms.